Hi, today we're going to be making one of these. It's a test box for a Whirlpool direct drive washing machine motor. You might need one if you're a service technician, or you could also use one if you're a do-it-yourselfer and you need a motor for a benchtop tool to run either forward or reverse. So let's get started. And what you're going to need are these parts right here, and I've put a link down in the descriptions where you can download these off my Canvas site. You're going to need a switch with 9 connections on the bottom side of it. You need a electrical project box, a Whirlpool capacitor, a power cord, some shrink wrap, some copper or aluminum insulated project wire, some forked spade terminals, and a cutoff plug like this one from an old washing machine, and some rubber grommets. So from this diagram you can make this box. It's pretty nice to have in your toolbox, and we'll go over how to do this, and it's pretty self-explanatory if you download this off the site. The first thing we need to do is prepare our switch, and the way we do that is like according to this. If you look at the switch, it's an on, off in the center, and on. It's got 2 ons and 1 off. So if you say this is an on, and make sure you have it oriented right. You don't, if it's on, you want the switch this way, and you're gonna jumper the wire from here to here, from here to here, from here to here. That's the start. So you don't want to have it sideways, or you'll blow circuits every time. So make sure that your switch is on going this way, and you jumper this way. And to jumper this, we're going to use some project wire, and I've got a few pieces cut, and let's see, I've cut them about 2 3/4 inches long, but we'll probably cut some more. But what you'll have to do, this wire was cut from an electric motor, an old electric motor that didn't work, and it looks like it's copper, but it's actually aluminum wire with a copper colored insulation, or varnished insulation on it. And what you have to do is you have to scrape that insulation off the ends where you're going to put it on your motor, on your switch. So you have to scrape that insulation where you can see the aluminum or the copper. If it is copper wire, make sure you scraped it well, because the varnished insulation looks a lot like copper. So anyway, when you get this scraped off, we'll go ahead and do our jumpering. So we've got it this way. And the first thing we want to do is, what I want to do is jumper this wire in the center. So I've already got this one kind of made up. And I want to make sure I get good contact. So just take a knife and just scrape around it real well, but you want to leave that insulation in the center of it, because you don't want to short out anything, because it's pretty tight in that box, and you're going to have to jam all that stuff in the box in your project box. So we've got that, and we've got our switch. So we're going to tighten this up. around this way. Now when you're doing anything like this, be aware of the way you wrap the wire around the screw. So you want the screw, if you're going to be tightening this way, you want to wrap it that way, because as you tighten, it'll pull the wire tight against the terminal instead of loosening it as you go away. So just like that. Okay, so we have the switches on this way, and we've jumpered across. Now we need a jumper this way, so we'll get another piece of wire, and I've already stripped this one. I'm just going to use a pair of needle nose to make an initial bend in it. Okay, under that, and over this way. Tighten that. I'm just going to cut off that little extra there. I like it pretty, and I want to make it sure it's clear of the center connector and clear of our other jumper. Now, according to our diagram, we need a jumper from here to here, and then from here to here. So, let's take another piece. And I need to clean that up a little bit. Always be aware of where you're oriented. So we're going to go from here back over to here. So we need, from about right here on, we need to strip insulation. I guess they just run this through a varnish vat or something, and as it dries, it insulates this wire. All wire and electric motors, it's not bare, it's insulated. When I was young, I always thought it was bare copper wire, but and come to find out, it had a varnish insulation around it. This is what I use. I guess you could use some other wire with regular vinyl insulation on it and do the same thing. However, I find this is it saves space, and it's fairly easy to do. let's get this one done. Alright. Looks like I didn't go far enough. Try to get a good connection because you don't have to go and do this twice. Always wondered why they didn't sell these things. I've never seen any for sale on the internet. I guess I could make them and market them, but I don't know if people would want to pay what it would cost to make. Making your own is always more fun anyway. Alright, and always keep it clean. Be sure you don't cut the wrong wire. Okay, we've got that one jumpered. Now we have to jumper this one to this one. Alright, let me pull another piece of wire here. These are really nice to have if you're on a service call and you have a customer whose machine's full of water and you've already jumpered the lid switch and it won't work. It's still something wrong with it. So what you can do, you can hook this device up to their motor, and possibly, if it's not a motor problem, you could possibly get it to work by putting it in the spin mode. It will drain the water out of a full tub of a washing machine. So they're real handy to have, and they are handy to have at the shop. I use it at the shop mostly for testing old motors, and a lot of times when I have it on the test rack. See, I almost did that wrong, didn't I? Always want to go where when it turns clockwise, it'll turn in upon itself. Okay, now we need to go across to here. So from this point on, Now, look at our diagram. We have a jumper from here to here, here to here, from the center to this outer one, from here to here. And that's what we'll start with. Okay, so we can set this aside for a minute. And let's pick up our washing machine connector. Now this is the plug. This is the plug that goes into the washer. And what you'll need, you'll see this is a white-black wire, a white wire with a stripe on it, and it goes into the center pole of the switch, this right here. So we're going to need this one, and here's the blue wire, and the blue wire goes over here, and your yellow wire goes here, and your green wire is ground to your power cord, and your red wire, if you look at the red wire up here goes to the capacitor. So the only wire you don't need is going to be this gray wire, so we can just clip it out of the bunch. So now we have our 5 wires that we're going to use. And we need to prepare them to go on the end here. And the way we do that is we use a spade terminal. Like this. Let's see what size these are. I'm using if you can see that, that's the ones I got, the 1614s, and they fit these screws pretty well. I guess you could use a little smaller one if you can find it, but they're really hard to find in small sizes. So, alright, the first thing you want to do is get you some shrink wrap. I'm using 5/16, and run all your wires through that. And you can buy this stuff in rolls. And this is heat shrink. And this will make your final project look good and keep all these wires from getting tangled and stuff. It's kind of tough to get this stuff through here, but it's too long. That's the way I can pull these wires easier. Pull from this end and it'll all snug up pretty well. Get it as far up there as we can. Now you've got a pretty setup here. It'll look something like that. Make this move toward the center better. So what you need to do is you take your project box, and I've already drilled 1/2-inch holes in each end of it, and also one in the top where the switch would go. So your wires are going to go in the ends, but you want it to be sort of waterproof, so you take a rubber grommet. You can get these at big box stores and all, and put a grommet in the end They're a little bit hard to get in, but you can do it with some effort. And it's good that it's hard because it makes it waterproof. Now, see there. Now you want to run all your wires to it. And then make sure you have enough wire inside your box. To shrink that a little bit. I'll take my heat gun and I'll do some shrinking on this end of it. And heat shrink tightens the wires up really well. And I'm just twisting it through there. Get it started so I can pull it the rest of the way. There. And you want to give yourself enough room in here to work. So, now I want to strip my wires back. You don't have to go too far. You're going to be putting forked spade connectors on it. Okay, and on your switch, on our switch we're going to have the white black wire, the yellow wire, the blue wire. We'll go to our switch terminals. That's the wire that's coming from the motor. So we can put the red and the green wire aside, and we put fork spade terminals. I get these right here. And these are the ones I use. You can see here, you get 20 in a pack, and it's called 16/14s. Okay, so we're going to crimp these on here using a good set of crimpers. I use these right here. These are real good pair. And they're color coded, red, blue, and yellow, and they match the spade terminal that you're going to be using. So I want blue, so I'm going to use this center notch and put it in there. Make sure your wire extends from the end a little bit, and also on the bottom end you want it to cover the insulation. That's a real good connection. One more. Okay, so we have those. Now, if you look at your diagram, the red wire, you want it to connect to the capacitor. So it needs to have a female spade connector that'll fit over the capacitor. So that's what we're going to use. So on it, I'll put the female connector. Again, I'm going to use the center slot for blue. And I'll probably use an inline connector for the green, because the green goes to the ground on the green will go to the ground on our power cord. So let's get that. So on the inline connector, be sure you don't get too far in the middle or anything, because you're going to have to crimp another wire in there too. Alright, we've got all our connectors on here. So at this time, why don't we get our power cord and put in there. Okay, for a power cord, I'm using a black one that I cut off an old machine and make sure that it's in good shape. And your power cord, you want to get it at least maybe 3 feet long, maybe 4, because if you think about it, you might be in a situation where you have to have your box down near the motor, because you're limited to the size of pigtail that you cut off of a washing machine, unless you want to do something like, splice more pieces on it. However, it's got to go through a grommet, so it'd be better to put it in the box and before you splice it. So let's go ahead and put the grommet on the other end of the box from where we put our washing machine plug. Our power cord will be coming in this side, so let's put our grommet in. And using these grommets really tidies up your job, keeps your wires from moving around a lot. You can also, if you have enough, you could maybe put a clamp or something on this, or even tie a knot in it to keep it from pulling out. So anyway, let's put our power cord through here, and it's real tight, so this side's probably going to be pretty much waterproof for your power cord. And leave yourself enough room to work with, because you can always pull them back out. Okay, so I'm going to strip this insulation back, being careful not to cut the inner insulation. Some tough stuff right there. Alright, there we go. going to go ahead and strip this wire back. There are better tools than a pocket knife for stripping wire, but I've just always found it more convenient to use a pocket knife. Okay, let's refer to the diagram again. So we know that our green wire from our power is going to connect the green wire to the washer plug. And we already have our connector here, so these two are going to go together. And one of the power lugs is going to go on one side of our switch and the other is going to go on the other. So we need to put spade connectors on those, fork spade connectors. Let's get a couple of them out. So we're going to need one for this white wire. One for the black wire. There we go. Now, one thing we haven't considered is we have another wire that goes here into the capacitor, and we cut our gray wire off of the switch. So what we'll do, we'll just strip it back and we'll put our connectors on it. So we know on one side of this wire we're going to need a forked connector. So this is going to our switch. And on the other end, we're going to need a female connector to go to our capacitor. And how much room do we need? Now, if you look inside this box, you don't need that much wire, so I'm just going to give it a liberal amount of wire. I can stuff it in there, but I'm going to give it about 8 inches. Alright, now we have our little jumper from the switch over. So now all we need to do is hook up everything. So let me clean up my workspace a little bit. So we're going to refer to our box here. So our switches on this way. So we have our jumpers. Our jumpers are oriented like we want them. So we need to put the yellow wire up in this corner, along with that jumper. And our white wire with the black stripe is going to go in this center terminal. And that's it right there. And while you're doing this, be aware, let's just turn this one around, because what we're going to have to do, it's going to be tight in this box, and we're going to have to bend these connectors over toward the center to get everything oriented where we can get everything in that tight box. So if you position these fork connectors where you can bend them toward the center, it'd be better. And while you're doing that, make sure you don't, like me, I just about disconnected that one. So if they have to share a spot, make sure you have enough room. Get out there. You must have want to fit in there with it. There we go. And it gets a little bit difficult to work when you get so much stuff in there with it. Alright, and our black white wire goes to this center terminal. And we also have a power. One of our power leads goes on that side too, so we'll have to share. So we have a power lead and black white wire. So let's put them together. Maybe we can cross them like this. Okay. Alright, so we have our yellow wire and our black white and one of the power. It doesn't matter if you have which power lead you have in there. You're dealing with alternating current, so it's going to be good on one side, good on then on the other. Alright, so we have this side done, so we need to put another power lead opposite this one over here. So we just turned it over. And remember, it's sharing with a jumper wire, so make sure you get good contact with both of them. We'll put our other power lead here. Alright, and our blue wire, if you reorient it, our blue wire is going to go on this lead right here. Okay, and let's reorient. Our capacitor wire goes in the center at the top. That's going to be way over here. Turn it over. Okay, so it sure looks busy. There's a lot of stuff in here. And it all has to fit back in this box. So what we need to do is we need to bend these over toward the center so that when it, and you can also bend them to the outside if you have to. Because they all have to be stuffed back in this box. Alright, while we're at it, we have the power, the ground. We can go ahead and connect that ground to the power cord. Alright, we should have all our crimping done. Now we just have to stuff all this stuff in this box. And it doesn't matter where you put your capacitor leads. Either terminal's fine. Remember, you're dealing with alternating current. So I'll put my red lead there and our jumper lead there. Okay, and I want to put my switch on this side, and my capacitor is going to sit in here like this. Now I can pull more wire out. And if you really want to, make this really strong and secure, I never have done it, but you can take some silicone and put it in the bottom and kind of glue that capacitor in there. But once you get all this wiring stuff back in here, everything's really tight, so it's probably going to fit. Alright, now we need to think about putting our top back on. And on these boxes, these are semi-waterproof boxes, and they come with a gasket that fits around this lid. I start in the center on one side, and I start pushing it in. Yeah, so now all we have to do is fit our switch and all this stuff into this box. And I like to go side to side. So what we'll do is you fit the toggle switch through the 1/2 inch hole. Now you fit your off bezel on it. There's a groove. There's a groove in the switch, and there's a pin in the bezel, and they fit together. And then you can either use the nut provided, or this thing, which has a nut on it itself. Get all this stuff going. Get it started and in the position you want, and tighten it all up. And I'm just going to finger tighten it. I'll come back with the appropriate wrench and tighten it down. Now we need to fit all this stuff into this box. So it's a tight fit. fitting. Throw some screws in it. Opposite corner. It's a tight fit. It's going to be waterproof or water resistant. Alright, now we should go ahead and shrink this. Put your heat shrink around your motor plug. It tidies everything up. And there we have it. Yeah, that's a test box for washing machine motor. All we need to do is label it, agitate and wash, and we'll give it a test. Okay, so I have our box. I have our box plugged in, and it's plugged into the table. All we have to do is test it. So, contact. Yeah, works that direction. And now let's see if it'll go in reverse. It does. Success. So we've made us a washing machine motor test box. Every technician needs one. See you on the next one.